Hello dear students, welcome back to chemistry class. We have already learned about chemical formulas, isn't it? So in today's class, let's quickly have a look at what we have already studied and also the chemical formulas of a few more important compounds. We know that in simple words, chemical formula is nothing but the representation of a substance. A chemical formula gives us an idea about the symbols of the elements or the radicals that are present in the compound, and it also tells us about the number of atoms of each element that is present in the compound. Now let's take an example for this. A compound sodium chloride. The chemical formula of this compound sodium chloride is NaCl. Now this chemical formula gives us an information about the symbols of the elements that are present in this compound. That is, Na is the symbol for sodium and Cl is the symbol for chlorine, or otherwise we call it as chloride. And it also tells us about the number of atoms of each of these elements that are present in the compound. Now this chemical formula tells us that number of atoms of sodium is equal to 1 and the number of atoms of chlorine, that is also equal to 1. Now, let's have a look at few important things that we need to know before we write a chemical formula. Always remember that you should be thorough with the valency of the elements and the radicals and also the symbols of various elements and radicals in order to write a chemical formula correctly. Now, let's have a look at the 3 important steps that we need to know before we write a chemical formula. The first step is that we need to write the symbol of the element or radical along with its valency. The second step is that we need to interchange the valencies of the elements or radicals. And the third step is that after interchanging the valencies, write the interchanged number and hence we can derive at the formula of the chemical compound. Now let's have a look at few of the examples. Now let us see how do we derive the chemical formula of the compound magnesium chloride by following the 3 important steps. So the first step is to write the symbol of the element along with its valency. So now in this compound magnesium chloride, we know that the symbol of each of these elements, the elements that are present are magnesium and chlorine. Now we are going to write the symbol of each of these elements along with its valency. We know that the valency of magnesium is 2 and it has a positive valency. Likewise, the valency of chlorine is 1 and it has a negative valency. So first we are going to write the symbol of the element, that is Mg, along with its valency. So we write it as Mg2+. Likewise, on this side, we write the symbol of the element, that is Cl for chlorine, along with its valency. So Cl1-. Remember that these valencies are written as a superscript to the symbol of the element. Now, the second step is to interchange the valencies of the elements. Now, this magnesium has got a valency 2. After interchanging, this 2 will now be written under Cl. Likewise, chlorine has a valency of 1. So after interchanging, this 1 will be written under magnesium. Remember that in this second step, you need to ignore the charges. So now we write 1 under magnesium and 2 under chlorine. So what is the third step? It says that write the interchanged number. Now, along with magnesium, we write the interchanged number, that is 1. Likewise, along with chlorine, we write the interchanged number, which is equal to 2. So these numbers after interchanging, it should be written as a subscript to the symbol of the element, as you see here. So it will now become Mg1Cl2. Now remember that whenever there is a 1, you need to ignore that 1. So finally, we derive at the formula, that is MgCl2, that is after ignoring this 1. So this is the chemical formula of the compound magnesium chloride. Likewise, iron oxide. We know that iron has got variable valencies. So here when it is written iron 3 oxide, this means that now in this case the valency of iron is 3. So now we need to take the valency as 3 in this case. So now first we write the symbol of the element along with its valencies, Fe3 plus and O2 minus. The second step is to interchange the valencies. So now this 3, which is the valency of iron, will now go for oxygen, and 2, which is the valency of oxygen, will now have to be written under iron. So now after interchanging, we need to write it as Fe2 and O3, that is ignoring these charges. So it will be Fe2O3, and this is the final formula of the compound iron oxide. Next one is ammonium carbonate. Here also we write the symbol of the radical along with its valency. So here the symbol of ammonium radical is NH4. It has a positive valency and the valency is 1. So we write it as NH4 1 plus. Likewise carbonate, the symbol for carbonate radical is CO3. It has a negative valency and valency is 2. So we write it as CO3 2 minus. Now we need to interchange these valencies. So after we interchange these valencies, same like how we have done in these cases, what we get is NH4 2 times. So this NH4 should be put inside a bracket, and then 2 should be written as a subscript to that. And then CO3, which should be inside a bracket, and then 1 should be written as a subscript to that. So the difference here is that in all these cases we had only one element present, but in these cases we have a group of atoms. So whenever there is a group of atoms, to avoid confusion, you need to place that inside a bracket and then you need to write the subscript. So it will come as NH4 twice CO3 1. So we know that 1 will always be ignored. So the final formula will be NH4 inside the bracket, 2 as a subscript, and then CO3. So you call it as NH4 twice CO3. So this is the chemical formula of the compound ammonium carbonate. Now let's look at the chemical formulas of few other important compounds. Sodium bicarbonate. We know that the elements that are present in this compound sodium bicarbonate are sodium and bicarbonate radical. So first we need to write the symbol of the element and the radical along with its valency. So we write it as Na1 plus and HCO3 1 minus. Now secondly we are going to interchange these valencies. So we write 1 under the symbol Na and again 1 under the symbol HCO3. So after interchanging these valencies, what we get is NaHCO3 after ignoring this one. So NaHCO3 is the chemical formula of the compound sodium bicarbonate. Likewise, calcium phosphate. We know that the elements that are present are calcium and also phosphate radical. So we write the symbol of the element along with its valency. So Ca2 plus and PO4 3 minus. Now after interchanging the valencies, what we get is Ca3 and PO4 twice. So when you write this PO4, you should put it inside a bracket. This is because this 2 is for the entire group of atoms as we have seen in the previous case. So we write it as PO4, which is inside a bracket, and 2 should be written as a subscript to that, and we call it as PO4 twice. Now Ca3 PO4 twice, which is put together. Now this is the chemical formula of the compound calcium phosphate. The next one is nitric acid. We know that the elements that are present in this compound nitric acid, they are hydrogen and the radical NO3, that is nitrate radical. So we need to write the symbol of the element and the radical along with its valencies. So we write it as H1 plus NO3 1 minus. After interchanging the valencies and ignoring this one, we derive at the final formula, that is HNO3. So HNO3 is the chemical formula of the compound nitric acid. Same is the case of sulfuric acid. The elements that are present are hydrogen and sulfate radical. So after writing the symbol of the element along with its valencies and after interchanging these valencies, what we finally get is the chemical formula of the compound. So H2SO4 is the chemical formula of the compound sulfuric acid. Same is the case of carbonic acid and phosphoric acid. So the chemical formula of carbonic acid is H2CO3. Likewise, the chemical formula of phosphoric acid is H3PO4.